Hello, my name is Jim Bradley, and I'm the Math Club faculty sponsor at the College of DuPage. And the title of this video lecture is Math Club Work Product, the AMATIC Fall 2021 Contest Notes. The COD Math Club's mission has emphasis on problem solving and outreach. This video is shared with you in the spirit of each. AMATIC is the American Mathematical Association of two-year colleges. The problems should be within reach of high school students, but are not trivial. Although there are correct answers, there are often multiple ways of reaching them. The solutions are my way of thinking about them. Please have fun with this. I did, and feel free to share more broadly. The solutions I offer are mine, and so I own any mistakes, but my mates Peter Graybo and Jim Meducci contributed to this video in compelling ways. The answer I found are all correct, however. Let's read the first problem. Alice and Bo are standing at diametrically opposite points on a circular running track of length 2,000 feet. Alice starts walking clockwise at a rate that is constant, and Bo, who walks faster, walks in his constant rate at the same moment, departing as Alice, and he walks counterclockwise. They meet for the first time 2 minutes later. If Bo instead walks clockwise, they meet 10 minutes later. Find how fast Alice walks in feet per minute. Feel free to pause this video and try. You're neither being graded nor timed. Enjoy the thinking. If you found the correct solution, congratulations. Even if not, you're richer for your effort. This is my solution. I let R1 be Bo's rate and R2 be Ann's rate, or Alice's rate rather, and I set up simultaneous equations, solve them, and the answer is D. Number 2. A number A is randomly selected from the open interval 0, 1, and a number B is randomly selected from the open interval 0, 2, and a number C is randomly selected from the open interval 0, 3. What's the probability that A is bigger than B is bigger than C? Feel free to pause and try. You are neither being graded nor timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your efforts. My solution follows. This inequality says that they're all in 0, 1, and the probability that A is in 0, 1 is, of course, 1. The probability that B is in 0, 1 is 1/2, and the probability that C is in 0, 1 is 1/3, so that is 6. But if these three numbers are 1/6, so if these three numbers are selected from 0, 1 randomly, then there are 6 equally likely orderings, and so the probability that this is the ordering is 1/6. So 1/6 times 1/6 is 1/36, and the answer should be D. Number 3. A star is formed by extending the edges of a regular hexagon with side length S as shown. This is a picture. What is the total area of the entire star, the hexagon, and the 6 triangles? Feel free to pause and try. You're neither being graded nor timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for the effort. My solution is shown here, and the correct answer is C. Number 4. How many ordered pairs xy, real ordered pairs xy, with the absolute value of x less than or equal to 2, the absolute value of y less than or equal to, are solutions to x squared plus 2x sine xy plus 1 is equal to 0. Feel free to pause and try. You are neither being graded nor timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your effort. My solution follows. X is not equal to 0 by inspection, so I can solve for sine xy this way. If I look at the graph of the right-hand side, I see that there are only two values of x, here and here, where this could be within the range of the sign between -1 and 1. So that means that there are two values, and it didn't ask for the solutions, but these are the solutions. So the answer to this problem is C. Number 5. Find the sum of all real solutions to x squared plus ax equal bx plus a plus 7 if a is defined piecewise in this manner and b is defined piecewise in this manner. Feel free to pause and try this problem. You are neither being graded or timed. Enjoy the thinking. If you found the correct solution, congratulations. Even if not, you are richer for the effort. This is my solution. So you see, the piecewise definitions say we're looking at intervals, Roman 1, Roman 2, and Roman 3 on the real number line, and I substitute these and solve. So in region 1, I find -8, and certainly -8 fits in there, so that is good. In region 2, I find two solutions, but only one of them actually is between 3 and 7, and so I have to discard this one. And in region 3, when I substitute in, I find that neither one of these numbers are there. So when I'm talking about the sum of the solutions, I'm going to be adding this one and the 4, and I get -4. So the answer is B. Here's number 6. If positive integers a and b are solutions to 1 over a equals 1 over 5 minus 1 over b, how many distinct values of a are possible? Feel free to pause and try. You are neither being graded or timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your effort. So what I can conclude is that b must be greater than 5 from the terms of the problem, and b must be less than or equal to 30, and a can be solved for b in terms of b. So there's just a bunch of things to try. We find out that there are 3 distinct values of a, 30, 10, and 6, and you see them there. So the answer is D. Number 7, the number 2021 has exactly 2 distinct prime factors, a and b. The number 2021 factorial can be factored into a to the m, b to the n, times q, where q is a natural number not divisible by n, b. Determine the absolute value of the difference between m minus, the difference between m and n. Feel free to pause and try. You're neither being graded nor timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you're richer for your effort. My solution follows. You can quickly determine that this factorization is 43 times 47. So that means that 2020 factorial has 42 factors of 47 and 47 factors of 43. Now, since a and b are not assigned, we don't know which is which, so the difference between the 42 and the 47 is 5 in absolute value, so our answer is E. Number 8, in a competitive soccer match, or tournament, I guess, a team that wins a match is awarded 3 points, the losing team gets 0 points. In case of a draw, a tie, each team receives 1 point. A 6-team round robin, each team plays 1 match against the other 5 teams, is played, and Liverpool finishes with no more points than any other team. What is the fewest number of points that Liverpool could have? Feel free to pause and try. You're neither being graded or timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you're far richer for your efforts. I think the best way to approach this, for me anyway, was process of elimination. I said, is 4 possible? And I decided 4 was not possible. Neither was 5 possible. Neither was 6 possible. 7 was possible because Liverpool could beat 1 team and tie everybody else. The correct answer is D. Number 9, suppose a, b, and c are non-zero real numbers. If ax squared plus bx plus c is equal to 0 has exactly one real solution, and f of x equal x squared over bx plus a has an oblique asymptote, the slant asymptote with a y-intercept of 0, 7, find c. Feel free to pause and try. You're neither being graded or timed. Enjoy the thinking. If you found the correct solution, congratulations. Even if not, you're richer for your effort. This is my solution. One solution to the quadratic means b squared minus 4ac is equal to 0. And what I can do is I can do polynomial long division here and find that the intercept of the asymptote is here, which means a equal minus 7b squared. I substitute it into this equation and I can find that b squared is, or that c rather, is equal to minus 1 over 28. The answer should be B. Number 10, 3 people, X, Y, and Z, are in a room with you. One is a knight, knights always tell the truth. One is a knave, knaves always lie, and the other is a spy. Spies may either lie or tell the truth. X says Y is a spy, Y says Z is a spy, and Z says Y is the spy. Which of the following correctly identifies all 3 people? Feel free to pause and try. You are neither being graded or timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are far richer for your efforts. The best way, I think, to approach this problem, at least for me, was to examine each of these answers. And so what happened is that I found out it was not E, it was not D, it was not C, and it was not B. But A is the only one that works. So I worked through it that way. 11. Square ABCD is inscribed in circle O. They all lie on the circle ABC and D, and its area is lowercase a. Now a square EFGH is inscribed in a semicircle of that same circle O. So they lie on E and F lie on a diameter, and G and H lie on the circle. What's the area of the square EFGH? Feel free to pause and try. You're neither being graded or timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you're richer for your effort. Here's my solution. So the inscribed circle has the length of its diagonal is twice the radius of the circle. So that means the area is going to be, well, each side then has a length of the square root of 2. R, and so the area is the product of the sides, so it is 2r squared. So that is what lowercase a is. Then when I look at the inscribed square inside the semicircle, I can use the Pythagorean theorem. I know that r is equal to the square root of a over 2, and I apply the Pythagorean theorem, and I conclude that s squared, the area of this inscribed square, is 2a over 5. So the correct answer is B. This is number 12. Consider the graph of the following function in polar coordinates r equal 2 over 1 plus cosine theta. This graph can be represented in Cartesian coordinates in the form ax plus by plus cxy plus dx squared plus ey squared equal 1, where to find the sum of the absolute value of a minus b plus the absolute value of c plus the absolute value of d minus e. Feel free to pause and try this problem. You're neither being graded nor timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your efforts. It turns out this is in polar coordinates, is a parabola with focus at the origin. And if I can take 3 values of theta, 0, pi over 2, and 3 pi over 2, and plot the points, I see that this is y squared equal minus 4 times the whole of x minus 1. So what I can do is I can use the form that we described up here, and that ends up being 1/4 y squared plus x equal 1. And I identify these coordinates, and I calculate this thing we're supposed to calculate, and I get 5/4. So the answer is B. This is number 13. If one BTC is 47,686, one ETH is 1584 ADA, and 23,000 ADA equal 1 BTC, how many ETH rounded to the nearest hundredth can we buy with $5,000? Feel free to pause and try this problem. You're neither being graded or timed. Enjoy the thinking. If you found the correct solution, congratulations. Even if not, you are far richer for your efforts. My solution is shown here. It's basically dimensional analysis, substituting the values in, and the answer should be B. Here's number 14. Suppose that a, lowercase a, is real. I, as usual, is the square root of -1. And the real part of this quotient of complex numbers is 19/25. Find the sum of all possible values of a. Please feel free to pause and try. You're neither being graded or timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your efforts. My solution comes pretty much straightforward calculation. We multiply by the complex conjugate and get this as the real part, and we set that equal to 19/25. We cross multiply and get a quadratic to solve. Yes, this quadratic does factor, and so one solution for a is 56/19, the other is 1. You add them together and you get this, so the answer is C. Problem 15. Let f of x equal logarithm base b of x and g of x equal x squared minus 4x plus 4. So if f of g of x equal g of f of x equals 0 has exactly one real solution and b is greater than 1, find b. Feel free to pause and try this problem. You are neither being graded or timed. Enjoy thinking. Okay, so looking at f of g of x, we conclude from this that x is either equal to 3 or x is equal to 1. But both of these conditions must be satisfied. Looking at the other way, g of f of x, we do this and we find that logarithm base b of x is equal to 2. Now we know that x could not be 1 in this case because b is greater than 1, so x has to be 3. But that means from this that b squared is equal to 3, so b is the square root of 3, and the answer, in fact, is B. Number 16, how many 6-digit passcodes are possible if repeats are allowed, and any passcode containing at least one 5 must have at least one 8? And note that passcodes may begin with a 0. Feel free to pause and try this problem. You are neither being graded nor timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your efforts. My approach was to focus on the number of 5s. So you can calculate that no 5s, the number of ways that can happen is this number here. And then if you have exactly 1 5, exactly 2 5s, and 3 5s, and exactly 4 5s, and exactly 5 5s, you can count the number of ways to place the 5s and the number of ways to place the 8s to complete the code. And you have to take these products and add them together, and this is your answer, 730703. And so the correct answer is A. Problem 17. Find the point in time between 4 and 5 o'clock when the hour hand and minute hand of the clock will point in exactly opposite directions. Express your answer in the form hour, minute, second, where second is rounded to the nearest second. What is minute added to second? Feel free to pause and try this problem. You're neither being graded nor timed. Enjoy the thinking. If you found the correct solution, congratulations. Even if not, you're richer for your effort. This is my solution that you can see here, and the correct answer is E. Number 18. 4 people are to be seated in 6 chairs at a round dinner table. How many different seating arrangements are possible if, for each person, we're concerned only with which 1 or 2 people occupy the 2 chairs beside them, with no distinction between left side and right side, nor orientation? For example, if 2 arrangements both result in A sitting next to B only, B sitting next to both A and C sitting next to B only, and D sitting next to no one, then they are not considered to be as different arrangements. Feel free to pause and try this problem. You are neither being graded nor timed. Enjoy the thinking. If you found the correct solution, congratulations. Even if not, you are richer for your efforts. My approach was to focus on how many people were in between the empty chairs. And so if there are 0 people in between the empty chairs, these are the possibilities. But some of them overlap with each other by the consequences of the problem. So what happened is the butterscotch matches, the yellow matches, and the gray matches here. If there's 1 person in between it, it could be A, B, C, or D, but we look at these possibilities and we eliminate the things that match. And similarly, if there are 2 in between, we have a number of possibilities. It turns out we have this. Now, if there are 3 people in between the empty chairs, that's really the same as 1, as number 1, having 1 person between the empty chairs. And if there are 4 people between the empty chairs, that's really the same as 0 people between the empty chairs. So I've already counted those. So I just matched this up. What we find is that this case there are 5 possibilities, this case there are 12, and this case there are 10 distinct possibilities. So the answer is D, 27. Number 19. 9 players are playing Texas Hold'em using a standard 52-card deck. This talks about what a 52-card deck is. Each player is dealt 2 cards and 1 player is dealt pocket kings. What's the probability to the nearest percent that another player is holding the only better hand, pocket aces? Feel free to pause and try this problem. You are neither being graded or timed. Enjoy thinking. If you found the correct solution, congratulations. Even if not, you are richer for your efforts. My solution is shown here. The probability of pocket aces to a single player given 2 kings are in his hand is there are 4 choose 2 ways to get the aces, and you only have 50 cards left to choose from because you have the pocket kings. And so you can do that calculation getting this, but there are 8 other players. So multiplying by 8, I get this, which I round off to 4%. So the correct answer is D. We've come to our last problem. John Conway's game of life is played on an infinite square grid, where some of the squares are populated with live cells, the black squares, to begin. Each turn, the grid changes based on the following rules. A live cell with 0 or 1 live neighbors, live cells in the 8 adjacent squares including diagonals, or greater than 3 live neighbors, dies, while each live cell with 2 to 3 live neighbors lives. The second rule, each unpopulated cell with exactly 3 live neighbors becomes populated with a live cell. 2 different starting states with 5 live cells are given. One will reach a steady state with live cells after m turns. M is the smallest value for which the grid is the same after m and m plus 1 turns, and the other will have no live cells for the first time after n turns. Find the sum of m and n. Feel free to pause and try this. You are neither being graded or timed. Enjoy thinking. So we started with this initial state and this initial state and just went through. And here I did describe things showing that we had births happening and lives, but then we found that everyone had died out by round 3. In this one, here we reached the firm state where this and this were exactly the same state, and so the answer is 7. hope you enjoyed these problems as much as I did. And remember, now more than ever, time is precious. Each day must count. Do the math, especially problem solving, and it will make you strong. Take care.